Okay, so recording and presenting. All right, so good morning. Assalamualaikum once again. Welcome to our final class today. As I mentioned today we'll be having our final class and we do two experiments. First one is detection of absorption maxima of potassium permanganate, and the other one is the determination of calibration curve. Both of them involves the instrument spectrophotometer. Okay. So before we go through the experiments, I want to explain a bit about the principles of the instrument, spectrophotometer. Okay, so this instrument is widely used in pharmaceutical industry. We use it to determine a lot of things. Okay, for example, kita boleh determine the concentration of substance. Kita boleh determine the identity. Kita boleh tahu what kind of substance, what kind of chemical compounds are within the mixture. Kalau kita ada satu jenis tablet, kita grind dia, kita mix dalam solvent, kita masukkan that solvent dalam spectrophotometer, that instrument boleh identify okay, how many what kinds of compounds are there, how many carbons there ada, how many oxygen ada, hydrogen ada, boleh detect. Okay, so before we go through the experiment, saya nak explain the principles of the instrument spectrophotometer. In our theory class, there's a chapter dedicated for this this instrument spectrophotometry. Chapter 6 kalau tak salah saya, kita tak sempat nak masuk lagi. So kita akan go through that in our next class. Okay, so in order, before I explain that, saya nak tunjuk one video. So this video is simple. It's a simple experiment dedicated for. So saya jumpa this video and I think it is like the most simplest, the most straightforward way of explaining spectrophotometry. Okay, so spectrophotometry basically what it does is dia akan check kebolehan sesuatu bahan untuk menyerap cahaya. So inside the spectrophotometer dia akan ada satu sumber cahaya. Sekejap, ada orang baru join. Dekat dalam spectrophotometer tu akan ada satu sumber cahaya, dia akan pancarkan cahaya. And that cahaya akan go through our solution. Okay, so and that solution akan absorb a certain amount of light. And this spectrophotometer akan measure berapa banyak cahaya yang diserap oleh solution tersebut. So from that from that measurement, kita boleh determine the concentration of a solution. Itu cara spectrophotometer measure concentration sesuatu bahan. Okay. And also satu lagi, that's one thing it does. Dia boleh measure concentration. Benda kedua yang dia boleh buat adalah dia boleh identify compound. Okay, macam mana dia boleh tahu UV spectrophotometer ni boleh identify. Okay, dalam this substance ada berapa banyak atom carbon, ada berapa banyak atom hydrogen, ada berapa banyak atom oxygen. Okay, dia boleh buat sedemikian kerana all these atoms absorb light. Kenapa dia absorb light? Because in all of the atoms there are electrons, and electrons move around the nucleus, as you have learned in your first semester, okay, the atomic structure chapter. So electrons bergerak mengelilingi nucleus. So kenapa dia bergerak? Because it contains energy. Kenapa it contains energy? Kenapa dia ada energy? Because it absorbs energy. And light is a form of energy. So bila kita pancarkan cahaya kepada sesuatu bahan, bahan itu akan menyerap cahaya. Kenapa bahan itu menyerap cahaya? Because every substances ada electron, and electron absorbs energy. and light is a form of energy. Okay, so that's why electron boleh bergerak mengelilingi nucleus, and proton and neutron, which is the nucleus, tidak bergerak because they don't absorb energy. So we know this behavior of electrons, dan dia menyerap cahaya. So kita boleh measure berapa banyak cahaya yang diserap. And electron juga, bila dia dah bergerak, dia akan memancarkan cahaya, just like us humans. Bila kita makan, kita absorb energy, and kita ada tenaga untuk bergerak. And bila kita bergerak, kita spread, we exert energy all around us. Bila kita tumbuk dinding, we exert energy. Bukan tumbuk dinding lah. Bila kita exercise dekat gym, kita tumbuk heavy bag, sandbag, we exert energy on the heavy bag, on the sandbag. Bila kita angkat berat, we exert energy on the floor. Bila kita angkat berat off the ground, off the floor, we exert energy off the floor. So just like us humans, electrons does the same. Bila dia absorb energy, dia akan move around. So bila dia move around, dia akan pancarkan balik cahaya. So bila elektron pancarkan balik cahaya, UV spectrophotometer boleh ukur berapa banyak energi yang dipancarkan. So from there kita boleh determine ini adalah elektron daripada atom carbon, ini adalah elektron from atom hydrogen. So different atoms exert different amounts of energy because different atoms have different amount of electrons. Okay, kenapa dia ada different amounts of electron? Okay, kita mudah belajar juga dalam semester 1. Tak semua all elements, all atoms mengandungi different number of electrons. For example, hydrogen bilangan elektronnya 1, helium bilangan elektronnya 2, carbon bilangan anak saya buat sini. Carbon bilangan elektronnya 12, and so on and so forth. Okay, so from kita tahu this details, this data, all atoms have different number of electrons, so they akan exert different amounts of energy. And UV spectrophotometer boleh measure the amount of energy yang dipancarkan oleh elektron lepas diserap. So that is how we can determine what kinds of compound yang ada di dalam sesuatu mixture. Okay, that's the principle. Macam mana UV spectrophotometer boleh measure concentration, satu, and macam mana UV spectrophotometer boleh identify. So bila saya kerja dekat dalam makmal dulu, saya always guna UV spectrophotometer ni untuk both of these things. Saya guna dia untuk determine the concentration. Kalau saya tak mau buat titration, katakanlah saya buka pharmacopoeia, kata nak test this ubat, nak test tablet ni, kalau nak buat titration tidak accurate. So dia suruh guna UV spectrophotometer. So saya akan guna dia untuk UV spectrophotometer untuk determine the concentration. Saya tak boleh guna titration sebab tak accurate kat depan. Okay. And also kalau saya nak buat identification test, samalah macam melting point test yang saya explain hari tu. Kita receive anything from other party, macam production department, kita perlu identify terlebih dahulu ini adalah compound tersebut. Kalau dia kata ini adalah glyphosate tablet, saya perlu buat identification test untuk confirm itu adalah identification test. Kalau dia kata ini adalah dextromethorphan sirap, saya perlu buat test untuk identify itu adalah dextromethorphan sirap. Okay, so saya boleh guna dia spectrophotometer untuk identify the chemical compounds, the active ingredients yang ada di dalam pharmaceutical drugs. So these two experiments yang kita akan discuss today will revolve around these two: determination of concentration and identification of compounds. Okay, so this experiment yang saya tunjuk kepada kamu ni smartphone spectroscopy. Okay, ini dia nak measure concentration. So bila dia measure concentration, the simple everyday bahan-bahan yang boleh tipu dekat rumah. So just a jar of water, air blackcurrant, 3 cawan kaca. Sorry, what was that? Lampu sudu, smartphone untuk download app light meter, and green filter. Okay, lampu kain plastik yang orang buat balut lampu bagi jadi colourful tu. shouldn't be anywhere. So smartphone kamu tu kamu perlu kalau kamu nak buat lah, if you're interested to do this experiments, okay, apa nama, DIY spectrophotometer. So phone kamu on your phone you need to download this app, light meter nama dia. So just any light meter app will do. So this is the light spectrum. Okay, cahaya yang kamu nampak every day, it contains this spectrum of colors. Okay, warna-warna pelangi. Kita tak nampak because all the other colors, all of these colors move at a different higher wavelength than what our eyes can see. So these are the ultraviolet wavelengths. Kita tak nampak. Tapi bila dia dibiaskan oleh air, kita boleh nampak warna-warna ini melalui the formation of pelangi, formation of rainbow. So spectrophotometer boleh detect these things. Okay, dia boleh detect from 200 nanometer wavelength to 800 nanometer wavelength. UV visible spectrophotometer. Sebab itu nama dia UV visible, ultraviolet to visible light spectrophotometer. Okay, so air blackcurrant warnanya purple. So kita nak detect kita nampak dia warna purple because dia absorb all of the other colors. Okay, cahaya yang dipancarkan, we see colors ni, kita nampak baju saya ni warna hitam because dia absorb all of the colors. So dia tak pancarkan sembarang warna. Sebab tu warna baju kita warna hitam. Sebab tu kamu nampak warna hitam. Sebab because bahan tu absorb all of the colors. Kalau kamu nampak apa color saya ada kat sini. Kalau kamu nampak sunflower warnanya kuning, okay, dia absorb all of the other colors tapi dia pancarkan warna yellow because the electrons of the flowers absorb all of the other colors, the energy of all the other colors, and dia pancarkan warna yellow. Okay, because all of the colors in the in the spectrum contains energy, a different amount of energy, wavelength. So a certain amount of energy is absorbed and a certain amount of energy is emitted, dipancarkan. That's why we see colors. Okay, so in this case blackcurrant warnanya purple. So kita nak check, kita nak measure how much color yang diserap, how much concentration is absorbed by the solution at different concentration. So we use this color. So kalau kita nak detect what color is absorbed the most, kita tengok this wheel color. Kalau color something tu warnanya purple, kita tengok the opposite, warna hijau. So warna hijau is absorbed the most. That's basically the rule of thumb. So that's why dia guna paper tadi warnanya hijau. Saya rewind. Biasa dia suruh guna warna hijau dekat sini, paper warna hijau as a filter. Okay, bila kita pancarkan lampu sulur, letak plastik ni dekat depan lampu sulur. Gunakan dia sebagai filter because kita nak pancarkan warna hijau sahaja. Because inside a spectrophotometer, saya cakap tadi ada sumber lampu, there's a light source, and after the light source ada satu filter nama dia. UV spectrophotometer diagram. This is also in the lecture notes dalam Google Classroom. Okay, so this is the keratan rentas, the diagram, simplified diagram of a spectrophotometer. Saya sepatutnya buka ni dulu tadi. Oh, my bad. Tunggu dulu. Nampak tak? Okay, so this is a simplified diagram of a spectrophotometer. So this is a light source. Lampu akan dipancarkan. Dekat sini akan ada entrance slit. Dia akan just allow a small portion of the light. Bila kamu buka lampu sulung ataupun lampu siling, dia akan pancarkan cahaya in all directions, kan? So bila kita dalam spektrum foton kita ni, kita nak just ada satu sumber cahaya yang from a straight line. Kita nak fokus, what's the word? Suluhan lampu yang fokus in a straight line, yang directed in one direction only. Because kita nak pancarkan cahaya from light source into a prism, and then into an exit slit and into our sample. So this portion, bahagian yang saya tengah circle with my mouse ni, ini dipanggil sebagai monochromator. So monochromator, from the name, mono means satu, chromator means one color. So kita nak just choose a specific color from the color spectrum. Okay, so this is the purpose of an entrance slit, a prism and an exit slit. Kita nak pilih just one color sahaja, one spectrum, one color spectrum sahaja to go through our sample. So the green wrapper yang diguna dekat dalam video YouTube ni functions as a monochromator. Dia pilih just one color from the light source which has all of the colors of the rainbow. Bila dia lalui wrapper warna hijau ni, spektrum color yang warna hijau saja yang akan dipancarkan, because warna-warna lain sudah diserap oleh this color wrapper. Okay, so and bila dia dah lalui this our sample solution ni, our solution akan absorb that light. Okay, and bila dia absorb the light, and cahaya yang dipancarkan after this solution ni, dia punya intensity, dia punya keterangan dia sudah berkurangan. So spectrophotometer boleh measure berapa banyak yang kurang. Kenapa dia kurang? Because cahaya sudah sedikit sebanyak sudah diserap oleh our sample solution. So the amount yang absorb tu boleh diukur oleh spectrophotometer. Okay, so that is why kenapa dia ada guna this green plastic wrapper tadi. Kenapa also kita perlu faham the wavelength, the UV visible spectrum, which is also learned dalam our first semester. Okay, this is an interesting thing. Kalau kamu tadi kan saya cakap, kalau kita nak measure what is the color yang paling banyak diserap, kita tengok this wave color, tengok the opposite. So kalau black color ni warnanya purple, kita tengok the opposite is green. Okay, so that means green is the most absorbed by this black current water, black current rain. So kalau kamu nak check that, kalau kamu nak confirm, kamu ambil gambar air black current, kemudian kamu invert. Kamu boleh use this in any app, photo editing app. So kalau kamu invert that that photo, kamu akan nampak the black current solution warnanya hijau. Okay, because this is the light spectrum yang diserap oleh air black current. Dia hanya pancarkan warna purple, the rest are absorbed, and green is the most absorbed by the drink. So you can do this, you can check this for yourself. So the test is, dia akan prepare 3 black current drink yang berlainan concentration. So in the first solution, concentrationnya rendah, and then sini makin tinggi, and sini paling tinggi. So macam mana nak prepare that solution? Kamu bubuhlah sini black air, measurement dia sama, katakanlah 50 ml dekat sini, 50 ml dekat sini, 50 ml dekat sini. Tapi in the first glass, bubuh 1 sudu besar black current cordial, and the second glass bubuh 2 sudu besar, and the third glass bubuh 3 sudu besar. So that is how you prepare a different concentration solution. Ini concentration yang rendah, ini tinggi sikit, ini paling tinggi. Because yang paling tinggi ini mengandungi paling banyak cordial black current, 3 sudu besar. Ini ada 2 sudu besar, ini 1 sudu besar. Okay, so the things that we do in chemistry is basically, kalau kamu faham, it's just everyday things. Cuma kita guna terms like concentration, units like molarity. Some people get intimidated and get confused. Okay, so that is basically it. Kita tengok kat sini the measure. The measure tadi, sorry saya dah. Okay, so kat sini dia letak lampu suluh yang dibalut dengan plastik hijau dekat depan. So only light green passes through this solution yang black currant ni. And dia letak smartphone dia buka light meter app. So dia measure how many cahaya yang passes through. And then they record lah the reading. Okay, so dia ambil bacaan in the first solution. Kemudian dia repeat the same step on the second glass. Ambil bacaan and then record. Let's see, be clear. And then dia buat. Okay, so as you can see here, the concentration goes lower. 380, 377, 251. So that means cahaya semakin banyak diserap. Kalau kepekatan solution itu tinggi, cahaya lebih banyak diserap. Kenapa? Because ada lebih banyak molekul black currant yang ada dalam cawan yang ada 3 sudu black currant itu. Kalau lebih banyak molekul, dia akan absorb lebih banyak cahaya. Okay, so this is known as the Beer-Lambert's law. So Beer-Lambert is a two-person team. They discover this pattern. So they made, they discovered this pattern and they explain it, they express it in an equation known as the Beer-Lambert's law. Okay, so dekat sini dia tunjuklah dia punya data dia. 100 ml air. All the glasses contain 100 ml water. And these are the concentrations of the black currant cordial. Okay, and the first solution kosong. And the second one 1. And then the third one 2, 3, 4 and so forth. Sorry. Sorry? ABC. Sorry guys. Asmani please. Asmani. Asmani dalam dulu. Okay, go Asmani. Okay, so this is how he created a different concentration of black currant water. And kat sini dia punya data. So in ayat kosong saja dia punya bacaan of the light that passes through adalah 552. Yang ada satu sudu saja 420. Yang ada dua sudu 312. And then 278, 255, 209, 180. So the pattern is the higher the concentration, the lower the light. Bacaan light. Okay, kenapa lower? Because semakin banyak cahaya diserap. Kenapa semakin banyak cahaya diserap? Because in higher concentrations of solution, there are more molecules to absorb light. Okay, so that is how we measure concentration. There are the equation here. I will show you later. And it is also available in the lab manual, Beer-Lambert's law. Okay. So that is how we measure concentration using the spectrophotometer. Let me open my playlist. So, mana dia tadi? So this is the second video that I want you to watch. They explain how the Beer-Lambert's law dan the iklan side. Hmm. Okay, so saya nak skip to Beers-Lambert's law. Okay, so this video also explains the same thing. Bila dia measure different concentration of solution, dia dapati the absorbance of light semakin menurun. Okay, so this is known as, kita kat sini, the Beer-Lambert's law. So kalau kita plot this data ataupun data yang dalam video tadi tu, the graph should be a linear graph, a straight line going up. Macam ditunjukkan dalam video ni. So kita buat graph absorption, penyerapan versus concentration, kepekatan. So the higher the concentration, the absorption, kadar penyerapan should be higher also. So that's why the graph should be a straight line, a linear graph. So this is the Beers-Lambert's law. So kalau kita nak measure any concentration ataupun calibration curve, kita panggil dekat dalam analysis, in analysis method of analysis, kalau kita ambil lah any solution, kamu kalau kamu buat air teh dekat rumah, kalau kita nak measure the calibration curve, the concentration of the solution, kita prepare in different concentration of tea, masukkannya dalam spectrophotometer, the graph should look like this, a straight line, a linear graph, naik ke atas. Because the law says, the higher the concentration, semakin tinggi kepekatan sesuatu larutan, semakin tinggi kadar penyerapannya, semakin banyak cahaya dia boleh serap. Kerana ada banyak molekul, there are more molecules of substance, of matter in higher concentrated solution. Okay, so this is how we determine the calibration curve of any solution. Whether our spectrophotometer is functioning well ataupun tidak, because that's one of the things also. Our instrument tu sama lah macam kereta, kalau kita tak servis dia, kita tak jaga dia, dia akan rosak. So our instrument dekat dalam makmal, we also need to calibrate, kita kena servis dia. So this is one method untuk servis instrument, untuk calibrate instrument tu, untuk check whether it is functioning dengan betul ataupun tidak. So kalau kita just ambil a standard solution with high purity, they prepare a different concentrated samples, 5 samples, and then kita check dia punya absorption calibration curve. Kalau calibration curve dia straight line macam ini, maksudnya that spectrophotometer instrumen itu berfungsi dengan baik, boleh guna lagi. Kalau kita plot graph dan dia bengkang-bengkok, dia melengkung naik ke atas ke, dia melengkung turun ke bawah ke, ataupun dia berterabur, so that means that instrument spectrophotometer tu sudah bengong, dah tak betul dah, something needs to be fixed. Sama lah macam kereta, kalau kita buat test kalau kita buat speed test ke, kita buat RPM test pada dia ke, kita tukar minyak enjin, tukar minyak hitam, tukar minyak ATL, check balancing alignment semua, tapi dia still tak berfungsi dengan baik, that means something is wrong, kita kena check and repair. Okay, so the instrument dalam makmal needs to go calibration. That's why nama dia kat sini, find the concentration of a solution via calibration curve. Because the calibration curve should go in a straight line like this. Because it obeys Beer-Lambert's law equation. Sorry guys, berat ni kenapa? Okay, put it in. Okay, done. Jangan angkat. No, heavy. Satu yang kena pakai saja. Sorry guys. Okay, so dekat sini dia ada tunjuk. Saya akan berlorong. Saya nak fast forward tadi. These are all the pemboleh ubah yang ada dalam equation Beer-Lambert's law. Intensity of light, keterangan sesuatu cahaya before they go to our sample. This is our sample solution. And then this is yang dot ni adalah intensity of outgoing light. Bila cahaya sudah diserap, dia punya intensity sudah berkurang lah. Okay, this is also another variable pemboleh ubah dalam Beer-Lambert law equation. This is the path length. C ni path length, kelebaran sesuatu kalau dalam spektrofotometer bekas yang kita isi solution tu nama dia QVAT. Okay, dalam video yang saya tunjuk tadi dia guna cawan kan. So kalau dalam spektrofotometer nama dia adalah QVAT. Basically dia adalah satu a cube of glass ataupun quartz mineral yang kita letak that we put our sample solution in. So the kelebaran, the length of the QVAT also plays a role dalam Beer-Lambert's law. Selalunya panjang ni lebarnya adalah 1 cm. And sini adalah constant, nama dia adalah molar absorptivity. Okay, so these are the variables of the Beer-Lambert's law. So this is what the law looks like. Log 10 I naught divided by I equals to epsilon LC equals to absorbance. Okay, so this is the Beer-Lambert's law. It is ada tertera di dalam your lab manual. Kira tak ada. Oh, this is a new one. Afiq tak boleh. Yep, Afiq. So, because saya ingat lab manual yang lama. Okay, so kalau tak ada lab manual tapi dia ada dalam lecture note. My bad, sorry. Okay, so with that in mind, that is how we determine the concentration of solution, and also we identify the compounds yang ada di dalam any mixture, any larutan, any tablets, any suspension kita boleh detect, because the electrons in the atoms of the compounds absorb and emit energy at a different level, because different atoms have different amounts of electrons. Okay, that is the principles, the introduction for these two experiments. So let's get into the first experiment, not this one. Okay, determination of absorption maxima of potassium permanganate. So this is the experiment, the test that we use. Yang saya cakap tadi, kalau kita nak identify the compounds yang ada dalam any mixture. Okay, this is, kita boleh guna dia sebagai identification test because different compounds ada different absorption maxima. Absorption maxima maksudnya paling banyak what is the maximum wavelength yang that substance boleh absorb, because different substance macam saya cakap tadi absorb light at a different level. So lambda max ni adalah wavelength maximum. Kita measure the amount of energy of cahaya ikut wavelength. Okay, so potassium permanganate is our solution kat sini. Kalau kamu masuk magma, this is this solution is like all magma should have potassium permanganate as the standard chemical requirement. It's like everyday use kalau kamu masuk magma. Okay, potassium permanganate, this is the chemical formula. K is potassium, MnO4 is permanganate. So the principle here is stated simple, lambda max. This is the symbol untuk lambda. Okay, lambda max is the wavelength at which maximum absorption of the radiation takes place. Fancy way of saying macam saya cakap tadi, certain substance absorb different amounts of energy, and dia ada kebolehan untuk serap energy yang paling tinggi berapa banyak. So kita boleh all of these are measured already and ada stated dalam pharmacopoeia. Okay, so katakanlah kamu dapat ubat amoxicillin tablets. Okay, so kamu buka pharmacopoeia kata, oh okay, the lambda max of amoxicillin is 530 nanometer. So kalau kamu grind the tablets, masukkan dalam spectrophotometer, check dia punya lambda max 530 nanometer. So kita tahu that is amoxicillin tablet. Sorry. Sorry, anak saya nangis. Banyak kali gangguan. I apologize for the disruption. Mana saya stop tadi? Okay, materials and instrument required potassium permanganate, volumetric flask to prepare all the standard solutions, beaker, pipettes, cuvette, and UV-Vis spectrophotometer. So the procedure lebih kurang sama macam the first video yang saya tunjuk tadi. Prepare a dilute solution of potassium permanganate, approximately 1 milligram in 10 milliliter. So how do we do this? We measure 1 milligram of potassium permanganate, kemudian larutkan dalam 10 milliliter solution. Kalau kecil sangat, kita prepare solution dalam 100 milliliter. So darab dengan 10. 10 nak jadi 100, darab dengan 10 kan, 100 ml. So 1 mg ni pun kita perlu darabkan dengan 10. So timbanglah 10 mg of potassium permanganate, larutkan dalam 100 ml volumetric flask. Top up with water, shake. Kemudian masukkan dalam UV-Vis spectrophotometer, measure the absorbance. Ulang record. This is a table. Kalau kamu sama you should fill in lah absorbance. Set the wavelength dekat spectrophotometer tu 410. Tengok absorbance dia berapa. And then check pula 420 absorbance dia berapa. 430 absorbance. So you have to do all of this one by one kalau kamu masuk mama. So this is a tedious and lengthy experiment lah kalau kita masuk mama. So this should take like separuh hari. Because kita ada banyak group selalunya. And dekat mama selalunya ada satu saja UV-Vis spectrophotometer. So every group should take turns. Okay, because dia akan ambil masa. So kat sini kita boleh tengok which wavelength absorbance yang paling banyak. So kita boleh tahulah dekat mana wavelength yang paling tinggi, lambda max. So wavelength tu kita tengoklah, katakanlah bila kita isi semua ni, the absorbance paling tinggi adalah pada 590. So kita tahu, 530 here as expected, 530. So kita tengok after kita fill up all of the absorbance, tengok 530 paling banyak. So this is the lambda max. Kita tengok absorbance mana paling tinggi dekat wavelength mana. So kalau 530 paling tinggi, so 530 is the lambda max untuk potassium permanganate. This is the maximum wavelength where it absorbs the most energy, the most light. Okay, so then report lah the absorption maxima of lambda max of potassium permanganate is 530. That's it. Okay, so there's a video of this also. Saya akan share dalam WhatsApp later. This is a 5-minute video. Semua video yang saya share. So this video dia akan tunjuk step by step how you should perform your this test. Spectrophotometric analysis of potassium permanganate solution. So at first you need to prepare the stock solution. Stock solution is the milligram or 100 milliliter. So this is dia guna method dia sendiri. Dia timbang 126 milligram of solid potassium permanganate. So this will take some time. Oh, my bad. So after dia dapat 126 mg of potassium permanganate, dia akan dissolve that in water. This is volumetric flask. Volumetric flask, once again, tidak ada senggatan. It only has one graduation line dekat atas neck ni. After we fill up the volumetric flask with potassium permanganate, and we will top up the solution, this glassware with water until the line graduation line satu kita katakan. So that we know we have 100 milliliter of solution. So sekarang dia tengah wash all the potassium permanganate yang ada di dalam beaker yang ditimbang. This is important because kita timbang 112 mg, so kita nak mix 126 mg also. Kalau ada residue warna purple dekat sini, that means that is ada sedikit lagi of the 126 mg kita timbang tadi tak masuk dalam this. So kita nak masukkan everything ke dalam ni. So that's why dia duduk wash dalam this beaker sampai ada its clear solution. So after everything is inside the volumetric flask, tutup dia with the stopper, and then goncang dia macam dia buat tadi. Tunggang balik. Now we have a well mixed standard solution. That is one concentration lah. Kita perlu prepare multiple concentration. So kat sini dia tunjuk apa nama, ini 1 ml, ini 500 microliter, ini 100 microliter, and this is 1 milliliter. So different concentration of potassium permanganate. Okay, so this is microliter unit there. This is unit microliter, 100 microliter, 200 microliter, 500 microliter, and 1 milliliter. So ini concentration yang paling cerai, paling cair sekali. Ini tinggi sikit, ini tinggi lagi, ini paling tinggi. Okay, so after that dia akan buat macam dalam that apa nama procedure tadi, dia akan measure one by one. So, that's my mouse. Okay. All right. So that is how we identify determine the calibration curve. So kalau kita plot, no, this is not the, my bad. Okay, this is how we determine the absorption maximum. So kalau apa nama, kalau kita nak kalau kita dapat satu ubat, kita nak detect whether ubat tu mengandungi potassium permanganate ataupun tidak. Kita scan the ubat, kita grind tablet tu. Okay, kalau kita dapat satu tablet, kita grind tablet tu, masukkan dia dalam solvent, larutkan dia dalam any solvent, water ke, alcohol ke. Bila masukkan that solution dalam spectrophotometer, scan at 530. Okay, kita apa nama check at wavelength 530 ada absorption maxima tak. Kalau ada absorption maxima at 530, that means that tablet contains potassium permanganate. Okay, that is how we identify certain compounds ada ataupun tidak di dalam mixture. Because certain every compounds contain different absorption maxima. Okay, that is the purpose of determining absorption maxima. That's the first experiment. So in our second experiment, kita push through saja lah, because this is practically the same thing. Determination of calibration curve, which kita dah buat tadi basically in our first video yang pakai smartphone and everything tu. Kita prepare also dalam video yang baru kita tengok tadi, kita prepare different concentration of solution, then kita measure saja what is the absorption. So dia punya apa nama, dia punya material instrument required is pretty much the same macam tadi. Kita perlukan potassium permanganate, volumetric flask, beaker, pipette, cuvette, and UV-Vis spectrophotometer. So kalau kita ada dekat makmal lah ni, I would schedule this to be on the same day. Pagi kita buat eksperimen yang dekat atas ni, absorption maxima. Petang kita buat apa nama, calibration curve. So procedure is pretty much the same. Okay, kita timbang, larutkan dalam solution, and then prepare different concentration of solution. So kalau kamu buat dalam makmal, kamu boleh latihlah skill kamu menggunakan all this glassware, guna pipette dengan bulk tu, macam nak measure using weighing balance, timbang stabil tak stabil. Kemudian kamu record pada concentration 10 microgram per milliliter, what is the absorbance? 20 milligram per milliliter, what is the absorbance? Okay, masukkan dalam solution ni dalam UV spectrophotometer, record the absorbance. Sampailah kamu dapat absorbance of these 5 solutions. Kemudian kamu plot a graph. Okay, absorbance versus concentration macam dalam video tadi. Okay, absorbance paksi Y, concentration paksi X. So kalau kamu add concentration 10, absorbance dia berapa? Concentration 20, absorbance dia berapa? 30, absorbance dia berapa? Kemudian kamu tarik satu line. Kalau kamu dapat line yang linear, straight line macam dalam video tadi, that means your solution and your instrument obey Beer-Lambert's law. Kalau dia dapat bengkang-bengkok, okay, bengkok ke atas ke, bengkok ke bawah ke, berterabur ke, that means something is wrong lah. Whether your preparation of solution tak betul ke, something is wrong, ataupun your instrument is need to be calibrated, perlu diperbetulkan. Okay, so for this second experiment melibatkan UV spectrophotometer ni, you should plot a graph. So in our assessment dalam Google Classroom later, saya akan kamu tak perlu plot graph, tapi akan ada soalan lah yang melibatkan graph. Okay, so that's it untuk absorption maximum and determination of calibration curve. Do you have any questions? You can raise the hand. Alright, so saya nampak kat sini, saya nak tanya tentang, because saya guna attendance yang automatically record kalau bila kamu join. So bila saya nampak kat sini macam Faris Iskandar ada tak? Because dalam attendance saya ni, nama kamu tak light up. Saya buka. Tak ada. That's why saya buat salah. Because the other day ada yang nama kamu saya nampak, tapi bila saya check attendance tidak ada. Nur Aini Hafiza. Ada sih, I see your name here, tapi dalam attendance tidak ada. Biasa tanda. Okay, you attend. Who is Dapo Maya? Okay, Dapo Maya tak ada dah. Nurul Nabiha ada. Dia saya tanda. Fatin Najwa also ada. Izati ada. Atira Azhar also ada. Okay, alright, semua dah all accounted for. Okay, so color theory boleh padam UV-Vis. Okay guys, so kalau tak ada soalan, I think that concludes our laboratory class. So all the assessments will be a total of 4 sahaja. Saya dah bagi acid base. Okay, acid subject saya dah bagi, limit task for chloride saya dah buat, saya dah bagi dalam Google Classroom. So after today kamu akan ada 2 more UV spectrophotometer, determination of calibration curve and determination of absorption maximum. So only 4 sahaja. So selebihnya tu saya akan buat assessment melalui tutorial ataupun quiz. Because after this, saya kita ada about 2 more class before the end of the semester. Tapi saya nak buat kelas ganti 2 lagi. Ada 2 kelas ganti yang saya ada tulis dalam note saya ni. Okay, so a total of 4 classes lah. Okay, kita akan buat. Sekarang kita kalau dalam syllabus kita baru dalam chapter 3. So saya paling teruk pun saya nak habiskan pada chapter 5. Okay, so saya akan schedule that with your class later. So kalau tak ada sembarang soalan, see you in our lecture class next week. Okay guys, thank you for joining in. Let me stop the recording. Thank you for coming to my class and participating.